So let me explain what we are looking at and why. Today, we're going to be looking at proximity matching for clearing files. And this is something that applies to compliance, but it also applies to security, export control, and so on. Any item that needs clearance needs checking what's there. And proximity matching is an interesting approach because instead of looking for perfect matches, we're able to check things adjacent to each other. Now, if you've been in this field for a while, you'll be aware that essentially proximity issues have been a massive challenge regarding false positives and false negatives. This is especially true of open source software because open source software tends to be forked a lot and customized a lot. And sometimes in that process, things like the actual license change. For instance, you could have an original code base that was licensed under, say, MIT, and then it's combined with new code, which is licensed under GPL2, and the aggregate is then GPL2 licensed. So being able to work out what you've got, being able to check proximity or similarity to other things is a useful and underexplored field. Not enough tools try to make this elegant. Now, Armijn Hamel, someone who's been in this field for a very long time, has been working on ways that this could be improved. And these explorations do not assure us of great proximity matching, but they do assure us of a promising approach using an open source model. Now, his talk is recorded because he originally delivered it a short while ago, but we are going to be, as usual, ensuring that you have a platform to ask any questions you may have. In this particular case, we're going to direct questions to our main mailing list to ensure that, first of all, Armijn will definitely see them, and second of all, that you will be able to interact with the community regarding asked and answered. Before we get started, I'm just putting up our antitrust policy notice as usual. If you want to see the full policy, you can do so on the Linux Foundation website. If you have any questions, you can, of course, ask them at any time. And if you're a Linux Foundation member and you wish to, for example, talk to our counsel who specializes in antitrust, just reach out to me. Without further ado, let's jump into what Armijn is doing. And if you're not familiar with where we are with open source automation, this particular approach represents a bit of a leap forward. And it's a prelude to more complete results, complete technology we'll see at our automation summit, which is scheduled for May. Now, if there's any issue with sound quality or similar, just let me know and I will fix it. Let's dive right in.
All right, so I'm going to talk about something a little bit more technical, namely about how we can reimagine clearing of files using a technique called proximity matching. So just a little bit about me. I'm an engineer, I'm not a lawyer. I used to work for GPLviolations.org doing enforcement in Germany. I'm no longer doing that. But these days, I'm mostly focusing on things like compliance engineering and binary analysis. And in my daily life, I help companies with open source license compliance, like doing things like builds for license compliance or M&A, fighting trolls. I think with the troll that we finally fought off with McCarty, I think I did 40, 50 cases. I don't know exactly, a lot. And I do things like audits. So whenever companies have something that they want to put onto the market, I basically help them do a scan and then do an audit. So one of the things that I want to look into right now, so today, is about how we can reimagine the open source clearing process. So when talking to people, what I hear about how clearing processes work these days, I must admit I haven't done a lot of clearing myself, luckily, but usually it comes down to something like this. So there is a system in that they scan files, So first they filter all of the files that they already know that are previously scanned based on a cryptographic hash like SHA-256 or MD5. And then they clear the files using tools like code clone detectors or snippet matchers or uh, things like license scanners, security tools, and so on. And then results are stored in a database along with metadata about that particular file or package, like a cryptographic hash, file name, package data, and so on. And I think that this is a waste of time to do this for every file that you get, because it doesn't take into account some key characteristics of open source. So if you're looking at open source, you will see that when you're looking at two different versions of packages, that very often the changes in those packages, they are incremental. You will sometimes see radical changes, but very often the changes are just very minimal, just a few lines here and there. And especially if you're looking at adjacent versions, like or minor upgrades, those are almost identical. And with the clearing processes right now, for every file that you haven't explicitly already seen, you're starting from scratch and you have to go through that whole clearing process again. And I think that's just a waste of time. So, is there a better way? I'm telling you that there is. And one of the things that I first want to look at is, can we find out how close a new file is to a known file in an efficient way, and then use this information? So for that, I'm going to talk about a technique called locality sensitive hashing. So most of the hashes that people are familiar with are hashes where a small change in the input leads to radically different results. So if you have a file and you make an MD5 checksum and then you change one byte, you get a radically different MD5 checksum. And with these hashes, avoiding clashes is extremely important. But there is also another category of hashes where clashes are intentional, so they can be compared. And the more clashes you have between the hashes, the closer two files are. So these are called locality sensitive hashes. And a popular one is TLSH. And that was made by Trend Micro and specifically for finding closely related malware. So malware tends to be changed just a few bytes or rearranged to avoid detections with hashes like MD5. And they needed a way to detect malware that is very, very similar. So comparing two TLSH hashes gives you a distance, and a short distance between two hashes means that two files are very close to each other. So this works very well for certain kinds of files like BE, so that's Windows executable, and ELF executables, but it also works very well for source code. It doesn't work so well for other files, like files that are too short, that don't have enough entropy, like files with just one character, but then lots of them. It also doesn't work well for very large files or things like compressed files, like archives, but also pictures like JPEG, GIF, and PNG. So Trend Micro actually has an implementation in C++, and there also are bindings for Python, and there are some implementations in other languages as well. So it has been adopted by companies like Malware Bazaar, Virus Total, who made the Yara Swiss pattern matching tool, and also by me. I've been using it successfully for quite a long time. So what I did is just a small test. I had two files with GPL version 3, and in the GPL version 3 text, I replaced the first GNU with OSADL. The reason is that I also gave this talk for OSADL yesterday, and I'm just copying that example. So there's first some setup code where I import the library, then I read the content, and then I compute the hashes for each of those. So what you can see is that those hashes are very similar except for the first few characters. So for the rest, they are completely identical. And if I then compare them, then basically TLSH says me that there is a distance of 1, which means very, very close. So then I also did something else. I replaced all of the GNU with a space with, I changed that to OSADL with a space, and then I do something different. And then you can see that the hashes are already more different, but they're still quite similar, especially if you're doing this as a byte string, no, a bit string comparison, they will still be very, very similar. And then it says that the distance is 12, which is still quite close, but it's already a bit bigger. And with this, you can basically compare files through TLSH hashes to see how close they are. So TLSH is fairly quick, but not as quick as other hashes are, like MD5. So what if you need to compare millions of hashes or more? This is not hypothetical. I talked to a few companies, and I think that they said that in the last half year they compared 20 million hashes, or no, 20 million unique files that they just scanned. So the companies are scanning at a massive scale. So millions of hashes, that's not unrealistic at all. But instead of walking a list, like just doing everything sequentially, you definitely need a different data structure, like some sort of tree. And a solution that Trend Micro had was to use a thing called a vantage point tree with TLSH hashes. So what I did is they recently published, well, not recently, in 2020, I think 2020, I don't know exactly, but they actually presented a algorithm called HackT, which is used for efficient clustering based on TLSH, which you can find actually on GitHub, a reference implementation. And inside this code base is actually an implementation of this vantage point tree using TLSH. So what I did together with a few students from OS 3.nl, that is the system administrator studies at the University in Amsterdam, what I did is we made the code a lot more Pythonic instead of the original Python written by C++ programmers code. And we optimized the hell out of it and then turned it into a web service with Flask. And the result is that I now have a web service, which is that you can feed a TLSH hash, and then you will get, as a result, you will get a closest file from the web service. So the proximity matcher web service is based on Flask and Green Unicorn. It uses TLSH and the vantage point trees, and it allows you to find a closest hash very quickly. I'm saying a closest hash because there could be multiple hashes that have the same result, but this web service will only return one result. So that's why I'm saying a closest hash and not the closest hash. So the example implementation that I made is quick. So searching for a closest license text in 5 million license text from software heritage with some optimizations. Then if you just give me a license text and I compute a TLSH hash and feed it into the web service, then a maximum of 0.6 seconds, usually a lot quicker. I did a test with a mass lookup, so 275,000 TLSH hashes using 8 threads, about 33 minutes, but the machine that I have is actually quite slow, so it could be a lot quicker. Memory usage, not too bad, 104 gigs per thread at the maximum, and then 1 gig for some extra cached data as well. And this all in 230 lines of Python code, including comments. So it's very small, it's very quick, it's also clean, very easy to read, and it will be open sourced soon. So proximity matching already solves one part of our problem because now we can find a closest file. And if I have this information, then I can combine it with known information from the scans that we've done before for the other files. And now I can also compute a difference using Unix diff with the closest file that I found. Then I can show the difference with the closest file that I found by basically computing a diff and then displaying it. I can also grab the information associated with the closest file found. So for example, I already found that that a file that I had was from zlib, and then I can say, well, this is just one that is very close, so I can basically just copy the conclusion, like, hey, this is zlib. And but we can probably take this a little bit further by looking at where the changes happen in the file as well. So there's also a tool called SourceML, which parses a file and then annotates it with information about what kind of type each line or each token of a file is. So for example, is it an instruction? Is it a comment? Or maybe it's a function name or a method, and so on. And this allows me to find out if a certain part of a file is a comment or if it's actual code. So now I can combine this with information from the diff, and then I know, uh, I know what change was made, but also what kind of code was changed. So is the change happening in a comment or is it happening in actual code? And then as the next step, what we can do is basically make decision rules because we have every information that we need. We know what a closest file is in the collection of known files. We know where a change was made. We know what kind of information was changed. And then we can have things like rules with which you can decide, like a license rule. One rule could be rescan the file with the license scanner if a change was made in any of the comments. Or a security rule, like rescan the file with a security scanner if a change was made in the code. Another license rule would be if there's a change in the code, then just copy the old decision that we made about the license. Security rule could be if there's only changes in the comments, then don't rescan with a security scanner. And that allows us to do semi-automatic clearing of code, which should be a lot faster. So the implementation that I have right now, the proximity matching web service is working. It still needs some polish before I can release it. Uh, the other components that I mentioned, they already exist. SourceML is an existing tool. Diff is a very old Unix tool with lots of implementations like difflib in Python. But I still need to do some glue work. And quite a bit of the implementations probably also depends on internal company tools and processes and what kind of component catalog you use, or if you have something that was homegrown and so on. So I've not worked on that part specifically yet, but the proximity matching web service, that one is working and it's working well. So one thing that I want to say, because I already got this question from a few people, like, so, and basically they ask, so can we now ditch our snippet matcher? And I must say that this method is definitely not a replacement for a snippet matcher. It's something else. So this is not suited for finding small bits of code. So if you're looking for if one of your engineers copied something from Stack Overflow, this is not your tool. This is just to find out if a file you're scanning is close to a known file you already have. Also, you first need to create a baseline anyway. So this is not a replacement for other tools. It definitely can work in conjunction with the other tools, but it is not a replacement. What it can do is find different information. So it's not a snippet matcher. So if you want to want to read a little bit more, there is a defensive publication that I recently published, which you can find on tdcommons.org, and you can also contact me for a little bit more information at my email address. And then I'm ready to take questions.
Armand, thank you very much. I have one straight out the gate, which is when you have a defensive publication on this, this suggests you're pioneering some new ground in this field. And with that optic, do you think the defensive publication is something that would be regarded as the start of a family of innovations around this? Or is it like, okay, we've described it fully here, we're done?
That's a good question. So first of all, I'm using tools that other people already published and also described in papers and published under Apache 2 as well. So core of the stuff that I'm using, of course, could not be patented at all. But these days, it's just my default modus operandi that whenever I make something that I think is interesting, I just first write a defensive publication. I already had other people patent my stuff I don't want that to happen again.
That makes a lot of sense. A follow-up question is related to how broadly do you think this approach could be adopted, not just from the tooling you're making, but other existing tools out there? Do you see your tooling fitting into a pre-existing framework? Do you see it operating independently? And are you open to collaborating with various parties to get this type of support implemented across the market?
Well, there's a reason I made it as a web service. So of course, yes, I want this to be adopted widely because I think it just makes sense. I'm not the only one who's thinking that. I talked with Philippe from NextB the other day, and I know that he's thinking along the same lines with Matchcode. So his
Yeah,
one of his new projects. So I think that more people are now ready for this kind of solution.
yeah, and I'm going to get Philip to talk about match code at our automation summit. I think we'll be having him do a good presentation about this technology. Now we've got a question from Martin. Have you tested this with forked software where the license changed, like Elasticsearch?
I have not actually tested with actual software, but what I did is I tested a lot with lots of license texts. But yeah, I guess that I could just run a test with actual source code like Elasticsearch. It would be interesting to see what happens. There's still quite a bit that needs to be researched, like what is um, a good size knowledge base. Should I separate things like C and C code and Java code or JavaScript, or do I all want that to be in one knowledge base? That's something that I still need to test. I mean, I literally made this just a few weeks ago.
And the reason that you're here talking about it, I think, is because it might be the first time we've seen this particular type of solution in play. But as you say, there's a lot more to do around it. When it comes to the practical testing of this, how would you like that to go? How would you like us to get this battle hardened?
That is a question that I currently do not know yet. So I will soon be making this code available. And after that, I just hope that people will start making implementations and just play with it a lot. As I said, I literally just got this off the ground a few weeks ago.
A related question of sorts. You've been working on another tool, a binary scanning tool, for a while. Um,
Yep.
how do these two things work together? Are you going to market with both as a kind of a solution? What's your game here? What's your plan?
Well, so the proximity matching could be used for anything that you can express as a TLSH hash. And of course, TLSH works great for ELF binaries. So yes, I will definitely be using that in Bang to see if a executable that I find in a firmware is very close to something that I've already seen before. Because as you know, a lot of the devices that are out there on the market are very often just identical or near identical because of the choices that the SoC vendors and ODMs made. So I think that I can do quite a bit of interesting stuff there with binaries as well with this method. But it's basically anything that you can express as a TLSH hash, you could put into this search structure and then do searches.
And I mean, I can see, and the reason you're here today is because this type of tool has very broad implications. I can see people utilizing it for all types of information analysis, including in areas like patents as well as copyright. So, it's something I think we should have on our radar. We can talk about copyright and patents a lot. We can implement solutions by processes a lot, but ultimately, automation is the key to efficiency. And there's companies out there like Proactive Patents, which do automation around patents. There are companies doing automation with software. But here we have something interesting with pattern matching that's just available. It's coming out of our community domain, and it's coming from one of the most reputable actors in the space. So that's something to very much have on our radar. Martin has a question following up. He's saying, I assume this tool will suffer when companies use code obfuscation. What do you think about that?
Well, yes. But the thing with code obfuscation is it's not a good strategy. If as soon as you have some open source code and you start, then I'm going to obfuscate that to evade detection, then you also lose a lot of the benefits of using that open source code, because for every version that you're using uh, later on, so if you want to upgrade, you also have to obfuscate that. So it's an added cost. It's a stupid strategy for a company to follow. But yeah, it's uh, probably this tool would suffer then, yes.
A question came in from Jan. This is a very interesting one as well. He's saying he's not quite sure about the current state, that he understands it. As of now, the TLSH implementation allows us to find closely related files that came across analysis before. Is he right? But as long
He
as
is
the
right.
next, okay. And he says, but as long as the next step is missing, I will have to look into those that have been discovered as somehow changed to understand what has changed. So he's saying that you need to do forward analysis to use the tool. This tool works
Well,
on
you
stuff already.
always need to establish a baseline, of course.
Mhm.
It's not something that I cannot it concludes things just from a certain hash of yes, you need to have a baseline first. So you need to go through those files in your knowledge base first,
Mhm.
and so that is a given. But as soon as you have that information, then you can say like, okay, what files do I already know that are close to a new file that I'm scanning, and then you can make lots of. Uh, then I think that you can save a lot of time or do
Yeah.
more targeted a targeted investigation into a certain file.
Is this suggesting that we're looking at a situation for a stacking of tools? Not this isn't innovative. We always stack tools, but we're looking at a situation where you want to stack your CI/CD and your resulting knowledge base, and then have a tool like this for further analysis of TLSH.
Yeah, I mean, it's this is mostly that you don't have to go through yet another copy of zlib or libpng and all that. So I know that people I talk to, they say that they have looked at something like hundreds of copies of zlib and all kinds of things, and they're all slightly different. Then they scan it and it's like, oh, it's zlib again.
Mhm.
With a tool like this, you can already do a lot of you can basically filter out a lot of that stuff already and be much more focused.
Makes sense. And Jan, if that doesn't fully answer your question, you can send a follow-up, of course. Now, I'm not sure how many people on the call are usually working at a much higher level than this, but I can I can assure you that what's interesting is that if we can have good optics into the strategy and the implementation of solutions around process management and automation, we're obviously going to do a better job. Now, Armine's talk is touching on the bigger topic of automation. It's touching on one of the exciting new developments, but the bigger topic. And we will have an automation summit in May where you're going to get a huge amount of information about a lot of tools, all of them open source tools for open source compliance. And that's where you can say, oh, I heard this talk. There's some interesting stuff here, but I'm a little confused about how things fit together. And you can go and see a lot of the tools, a lot of the solutions, and a lot of the interlinks. All right, Armine, thank you very much for an excellent talk. Deeply appreciated. And I'm looking forward to having you at the Automation Summit as well.
So there we have it. It's something a little bit new. It's something a little bit different. And it is something that I hope we can talk more about. Like I said, we are going to have an automation summit. It's provisionally scheduled for somewhere in middle May. It'll be hosted by Oliver from Siemens. And of course, it will feature all the best and the brightest from our automation tooling work group.
I hope to have Armine give us some practical demonstrations at that event, along with Philippe, as we mentioned, and of course, the other teams working on other technologies like open source review toolkit. One of my personal goals during the forthcoming event will be to show how the tools interoperate. I think it would be very useful if we could make sure that open source review toolkit can very quickly call something like Armine's tool. And of course, we can have the tools import and export SPDX transparently. Now, because that was a recorded talk and because it is extremely early in the morning in Europe, Armine is not on this call. So questions to the main mailing list, please. That's main@openchanproject.org. We will be monitoring that for questions, and Armine has made it clear he's very happy to work with people on showing them previews and demonstrations of this technology. All right, we're going to wrap it there unless anyone has a question that I can answer at this point in time. All right, if there's no questions, thank you very much. And I look forward to seeing you at our bi-weekly work group call next week.